All right, everyone. So today we're going to do a full systems deep dive into the Swarm platform architecture. We're going to follow a single piece of data, a payload, all the way from the front door, through the core engine, and out the other side as a final concrete action. Okay, so here's our roadmap. We'll start with the big picture, the why. Then we'll follow the data through ingestion and into the Swarm engine itself. After that, we'll look at how it learns, how it makes a final call, and lastly, how it plugs into the real world and how we keep an eye on it. The whole journey, end to end. All right, first things first, let's just zoom out for a second. Before we get into all the nuts and bolts, we really need to understand the fundamental problem this whole thing was designed to solve. So what is Swarm, really? At its heart, it's an AI infrastructure platform, but it's built on three principles that are totally non-negotiable: deterministic routing, governed decision-making, and complete explainability. And that last part is so important. This thing is designed from the ground up to be the exact opposite of a black box. In any system where a wrong decision has real consequences, being able to trace why something happened isn't just a nice-to-have, it's the whole point.
Okay, section 2. Let's start tracking your requests as it comes in. This is the ingestion and specialization stage, basically how we get data into the system and get it ready for the heavy lifting.
The platform's designed to be super flexible with what you can feed it. We can throw raw text at it, low-level system signals, specific events, or really any kind of structured data payload you can think of. It's the universal front door for decisioning data. But here's the thing. Once a payload gets through that door, it doesn't just get dumped into a generic processing queue. Its very first stop is critical for adding context. It gets routed immediately to what we call a specialized domain pack. So you can think of these domain packs as, context-aware preprocessors. We might have a general router pack for handling web traffic, or a super-specific BTC or Binance pack that knows all the nuances of crypto trading signals. And of course, we can build custom packs for any new integration we dream up. They're what get the data ready for the main event. Okay, so the data is in, it's been cleaned up and contextualized. Now we get to the absolute heart of the system, the core decisioning engine itself, the Swarm engine. Once a payload enters the engine, it goes on a very specific journey. It's this exact 7-step pipeline every single time. This is what makes the whole system deterministic. The path is fixed. That means if you put the same input in with the system in the same state, you get the exact same output. No randomness, no surprises. Now, if we break this down, you can see a really beautiful, logical flow here. It all starts with parse, just normalizing the data, cleaning it up. Then score gives it a raw domain-specific score. Now, this is cool. Scout then looks into the system's memory and adds what we call pheromone bonuses. After that, specialist ranks everything and flags any conflicts. Verify runs some basic threshold checks, and then governor makes the final safe call on what action to take. And the last step, explain, bundles everything up into a completely transparent trace file. Of course, a decision engine that can't learn is just a fancy flowchart, right? It needs to get smarter over time. So let's look at the learning and memory layer, because this is what enables that crucial adaptive feedback loop. The system's ability to learn and remember is really built on these three pillars. You've got pheromone memory, which is for that quick adaptive feedback. Then there's the storage layer for long-term history, and finally a telemetry layer for deep operational data and auditing. And this is the part that's so important to get. These aren't just write-only log files. This data creates a persistent feedback loop. It feeds information back into the Swarm engine. Remember that scout step we just talked about? This is what it uses. The pheromone memory acts like these digital scent trails, making paths that led to good outcomes in the past more attractive for future decisions. It's how the system adapts and improves on its own.
And this table just shows you how granular we get with the data. The pheromone memory is tracking patterns for that adaptive feedback. The storage layer is using SQLite to keep a history of every run and all its versioning. And telemetry is capturing everything else. Performance metrics, confidence scores, distribution data, the full audit trail. Nothing is lost.
Okay, so the engine has done its work, it's consulted its memory, and it's come to a conclusion. Now what? It needs to package that decision up into something formal and, actually usable. This brings us to the final decision and action. And the output of all that processing is this, the decision object. You can think of it as the final report. It's a structured data object that contains everything: the class it predicted, the action it's recommending, the confidence score for that action, and, crucially, that full explanation trace from start to finish. It's the complete, auditable record of that decision. That decision object then gets translated into a concrete command for the outside world. So these are the actual system outputs. In a customer service world, that might be route, escalate, or block. In a trading system, it could be enter long, enter short, or just wait. The action is completely tailored to the domain it's operating in. Okay, last piece of the puzzle. How do these actions actually connect to the rest of our tech stack? And how do we monitor this whole thing to make sure it's working right? That's the integration and monitoring layer. The platform was never meant to be an island. The whole idea is for it to be a decision-making brain that you can plug directly into your existing business systems and APIs. It does the thinking, and your other tools do the doing. And that means the integration possibilities are pretty much endless. We can hook its outputs into a CRM, a messaging app like WhatsApp, an e-commerce platform like Woo, financial APIs like Binance, or we can go totally custom and connect it to a database, an end-to-end workflow, or just a generic webhook. And for complete eyes-on oversight of the whole operation, everything is piped into a live dashboard. This is our single pane of glass, our mission control for the entire platform. And this isn't just a bunch of high-level charts. It gives us a real-time visualization of routing. We can pull up the full explainability trace for any single decision. We can monitor the current state of the pheromone memory to see how it's learning. And of course, we have all the performance metrics and the complete historical audit trail. It's all there for debugging, for analysis, and for compliance. So that's it. That is the entire journey of a payload from raw input to a fully audited explainable action. It's deterministic by design, it's adaptive through feedback, and it's completely transparent. So I'll just leave you with this question. Thinking about the systems we all work on, how could an architecture that's built on these principles, how could that change the way we design and manage our own automated systems?